Good morning and welcome to the Trending Topics in Medical Education Research Symposium. We have, I think, 5 talks. I think one of our people couldn't come, one of which is recorded because of the visa issue. But our first speaker will be Tai-Chi Lin, and he's going to talk on research in medical education, similarities and differences with clinical research.
Okay, thank you, Carl, and nice to see you again. And Anna, this is my 3 years in a row talking in this session, but I'm from Taipei Veteran General Hospital, and I'm colleague with Angar Wong. So
okay.
Right.
Okay.
Unfortunately, he's somewhere else.
I was just in a symposium with him.
Yeah, it's a symposium. Right. So okay, can we pull out the slides, please? Okay, thank you. So I'll be talking about research in medical education and what is the similarity and difference with clinical research. So I have no financial disclosures. So first of all, what is a research in medical education? It is the research that aim to understand the learning process. So these studies, they assess the curriculum design, instructional formats, or how actually learning is delivered to students, program and performance evaluation, even faculty selections and efficacy, and most importantly, learning environments and culture. So above all these studies are actually trying to improve the ecosystem of medical education. So just to give you a little hint, these are the most cited topics related to medical education. So it gives you an idea, roughly, what are the most popular interest research topics inside this field. So how about clinical research? Broadly defined, it covers the dynamic of health and disease. And we're always trying to determine the cause and confounding risk factors. And then most importantly, to the preventive measures and the treatment of human illness. So it seems very different what these two studies are research types are focusing on. However, they do share a lot of similarity. First of all, there are many journals that actually you could submit a medical education paper. If you look up from the PubMed, there are so many different journals. So the thing you have to, the similarity as a clinical research, the thing you have to do is you look up each individual journals and you find that the scope fits your research topic, and then maybe it has a higher chance to get accepted by these medical journals. And if you actually ask ChatGPT, you ask them to build up a figure saying that what is the related article published through the past 10 years, we can find that not only just for the clinical research, but also for the medical education research as well. The numbers of these articles being published throughout is increasing every year throughout the past decade. So they also share this similarity. Okay, and then what are the other similarities? First, number one, I think, how do you actually build up a medical research education research is similar to what you do when you initiate a clinical research. First, you have to refine your study design, your study questions. You ask yourself and you review the literature. Is there a knowledge gap that is worthwhile research? And then you clear the state a problem. You clearly state this problem, and then you significantly try to address it. And finally, you develop a theory model or a theoretically contact that could fulfill this knowledge gap. So this is pretty similar to what we do every day in the clinical research. And the similarity number 2, define your outcomes. Ideally, you would assume that these dependent variable of the study should answer the question that you are asking. However, sometimes it may not happen this way. You need to challenge the predicted outcome. Which meaning that what would the study suggest if the prediction was proven to be true or false? What is your story about related to this outcome? And then after, you have to have that before you even start to collect your data. So when you have your story, you collected information you needed and about the outcome in an unbiased manner. So this is also pretty similar to a clinical research. Similar to number 3, I think the study designs and the method are also pretty similar. It could be an observation study related to medical education research, but instead of observe the behavior of a patient, it is actually try to determine the relationship associated between these variabilities. It could also be experimental, and also qualitative research, and validation research as well, and surveys, and also systemic reviews, which are also pretty similar to the methodologies of the clinical research. Summary number 4, remember to obtain your IRB. That is a very important issue. You don't want your paper to be rejected because you didn't obtain your IRB. And sometimes this could be very difficult because the regulations between each institute could be different. So if you're initiating a multi-center medical education research, make sure that everybody has their IRB approved. But so they share so many similarities. But why do education research feel so different from the clinical research we do every day? I think this is mainly due to the researchers who are doing the medical research, education research. They have been trained, educated in medicine, and some of them do clinical research, which some of them may only do clinical practice. But when they have the chance to become the investigator in a medical education research, they may not be necessarily prepared to initiate this kind of research project. So that's why it feels very different. And what are the other differences? I think between these two research, there are a fundamentally difference existing between. In the clinical research, it's more like a physical science. It is what we have been trained and taught in the pre-med or medical school. It is based, the majority is about finding the answers that you are asking. But how about the medical education research? It's more like a social science. It could be talking about the difference in education strategies, which may in fact reflect the outcome of the students. And then above all, I think most importantly, learning is a very complex process. Different curriculum delivered by different teacher could end up with various outcomes. So it is kind of difficult to evaluate. And finally, the time between the learning and important outcomes may be so long. You have to wait it for the student to graduate and for them to develop their career to actually see did the outcome work out. So it's very difficult to initiate a longitudinal study in medical education researches. And they are also different in components. In clinical research, as I mentioned before, it's more like a physical science. So it contains physics, chemistry, biochemistry, and even geology. But regarding medical education research, because it's more like a social science, it's not just about education. Sometimes it contains a little bit of psychology, anthropology, and also sociology. So that's why the components are very different. And the participant in these two studies are also different. In the clinical research, there is always a PI, so either a MD or a PhD who is in charge of this research. There are research coordinators who actually do the day-to-day work of the research. There are sub-Is which help the PI. There are maybe CRA companies that they monitor the clinical trials. There are also pharmas and biotechnic companies who support the fundings and resource for the clinical research. There are data managers and biostatisticians who would do the analysis. They may be a regulation specialist to monitor the ongoing clinical trial. And you will have scientists working on the bench who may also involve in the clinical research. Sometimes governments, such as FDA and NIH, they will be supervising the clinical research. And finally, patients and volunteers are also an important participant in clinical research. But how about medical education research? Most participants in medical education, they are the medical school administrations. They may be also student affairs deans or leaders in curriculum developments, or sometimes curriculum directors and research program directors. So the participants could be very different. And finally, last but not the least, although they may be different in study design, but they are all seeking a evidence-based research. But you can see we are very familiar with the methodology of clinical research, such as randomized, double-blind randomized clinical trials, observation case series. It could be prospective, retrospective, or database, or even bench science. But in medical education research, it is more like describing a new curriculum, providing a prospect or a new method of assessment, or how these medical students are doing, how the residents are doing, or modeling a different learning behavior, or you actually compare before and after a new delivered strategy is given to these students. And how do they differ in outcome analysis? Although both studies types, they all aim to improve the outcomes, but in the clinical research, it is really major in the patient-centered outcomes, where the medical education research is more a learning-based outcome evaluation. And then in the clinical research, it's more objectively and quantified measurements, where the medical education research, they are more subjectively and maybe qualitatively measurements. And finally, in clinical research, mostly are focused on statistic significance. But in medical education research, the majority may just be a description statistic. So this is the major difference between the outcome analysis. So in conclusion, research in medical education shares similarities with clinical research. They are pretty similar in systemic methodologies, data collections, analysis to improve their outcomes. However, medical education research focuses more on the learning process itself, curriculum developments and teaching effectiveness, rather than a patient-centered clinical outcomes. But both fields, they emphasize the evidence-based approach. Clinical research usually relies on the high evidence randomized clinical trial and biological measurements, where medical education research frequently just incorporate with the educational theories. So understanding the difference and the similarity is essential when you try to approach the research methodologies in each domain. So I think at the end of the day, no matter what kind of research you are trying to initiate, I think the most important part is collaborate. You cannot do each kind of research on your own. Collaborate with the specialties and use their expertise will guarantee you a wonderful research path. I think.
Amongst those in recent times?
In recent times, I think it's more like the skill, like the skills, the education skills, like how we improve the education skills to improve our education outcomes. And I think another one is more like the evidence-based learning. We changed like the traditional curriculum to like a more interactive, evidence-based student learning method. So I think these are the popular topic in recent days.
And anything unique in medical education as opposed to overall changes in the way education is now being imparted?
I think there are more back and forth. But I think at the end of the day, the evidence base is more emphasized, and so everything goes from what the teacher delivers to the student. Turns out trend. There's a trend changing to the evidence-based learning. Yeah.
Thank you, Dr. Lin. This is not a question, but a comment. It's a very important topic, the one that you have discussed, because most of us teach, but not many of us are evidence-based. And the other thing is that doing research in medical education is a way of increasing our CV on research as well.
Yep.
So thank you for your talk. Our next speaker is Dr. George Saleh from Moorfields Eye Hospital. and he will be discussing research in simulation for teaching and learning in ophthalmology.
Oh, you're going to use your own?
Sorry, I spent a little while downstairs. They couldn't get the videos to work, so
Oh.
they said plug this in.
Okay.
So apologies, someone messed it up.
No problem. Take your time.
Oh, come over here, right? Now, what's happened? It's crashed. Is it?
Okay, we're having computer problems, so we're going to have our next speaker go first, and then once George has figured that one out. So our next speaker will be Pranesh Balasubramanian, who is going to talk about myths and facts of gamification in medical education. What has evidence demonstrated? Speaking of evidence-based.
Thank you, Dr. Kahl. It's an honor to share the stage with my mentors in ophthalmology and medical education. So this talk is on gamification in medical education, what evidence is saying to us. How many of you play games? Or have played games, should I say. But there is no age bar for games, right? So we're going to see how we can make use of games in teaching our medical students or residents. So we have got these 6 E's. The objectives will be these. We will explain the different terms, very confusing terms used in gamification, and we will learn the game elements which we can employ in our education. We will appreciate the various underlying learning theories with some real-world examples taken from the current evidence. And finally, we will summarize to look at the essentials of gamification in medical education. So I've made like a mind map. If you can scan this QR code, it will go to a mind map, which I am using to present this talk right away. This is an interactive mind map I'm trialing out with my audience in APAO to see if you can open and close the branches by yourself. So you can navigate along the talk as I'm talking through. Deactivated, I'm very sorry about that. I'll share you the activated one later. Great. So gamification. Like I said, it's using the game elements to enhance the learning of our students. The goal is not to entertain them, but rather to educate them. That's why they use the term serious games. And simulation is a close relative of games. Mr. Saleh will be discussing on that as well in the next talk. I see simulation as a form of a game, but some educationists differ in that aspect. Now, a game should have these following elements. Like a movie, the game should have a fictional scene. There should be some rules which has to be employed in that movie to create an immersive experience for our learners. And you will have these protagonists, the heroes, you will have the villains, the challenges. So imagine game like a movie. The journey to attain a common goal should have different levels of difficulty. And the most importantly, there should be immediate feedback, positive as well as negative. So these are the elements of a game. The next video has an audio. I would request the AV to enable the audio, please. How many of you played Mario? It's one of the very few games I've ever played in my life. And it's probably the most popular of all games. And applying the game elements to Mario game. So you have a fictional scene, you have rules there, you have Mario, the protagonist, he has to save the queen. That is the ultimate goal. And he has these different journeys. Audio, please. nostalgic music, right? So this exactly shows why I suck at playing games. I tried playing this last night, and was the result. So you can see that Mario is having the rewards. He is facing these enemies or challenges or the villains there. These are all elements of a game. And you want to take all these elements into combining with the existing curriculum or the content what we have. We are creating this game where the audience is going to use that game, which is supposed to modify positively the skills, knowledge, and the attitudes of the student or the learner. So speaking of which, let's move on to the next E, the educational theories underlying gamification. So what evidence is saying is that games are not simply for fun. There is a science behind why we play games and why we use games in teaching. The first is this experiential learning theory, where learners use their experience to build a concrete understanding of a topic, and by feedback, they are trying to solidify or cement their understanding. The deliberate practice theory is not just for games, but for all of us. How we can make use of intentional, mindful practice with regular feedback can improve our habits, can improve our skills. The social comparison theory is a bit controversial. It says that students react either positively or negatively by extrinsic motivation, by comparing themselves with their peers, like the leaderboards, what we have, who's ranked 1, 2, and 3. It can motivate, it can demotivate a student, which we'll discuss later. Some of the examples of games. Can you give me one example of a game which we commonly use, which is right on our phones, which some of you might be using very frequently, checking every day? Any guesses? It's there on this. The fitness trackers, probably the most related game. Always checking how many steps have I walked in this conference. Have I taken the steps or lifts? So this Fitbit Apple Watch gives us an exact application of games. It has rewards, it has streaks. Have you completed this task on day 1, 2, 3, 4? These are all very good models to use in our teaching. When it comes to medical examples of using gamification, I see two broad categories, although it's kind of blurred margins. Quizzing, by giving puzzles to solve, asking questions. That's one part of this gamification. The second broad category is using simulation. Mr. Saleh will be discussing about that in the next talk. The medical examples, like Prajana sir was mentioning the other day, how he uses his DigiNerve learning platform as a flipped class, and how he uses Kahoot as a useful tool to get the audience response. That is a game. For my students, I simply use the MCQ question bank, what they prepare for their exams. I pull up the questions, I even open up the real time, divide into teams, and I play a game. So game is something which you can use, you can personalize to your needs, to your skill level. It doesn't have to be really, you should have these things, so on and so forth. Jeopardy is another popular game show. Dr. Karl was mentioning the other day about how it's being used by the doctors in his university. My friend uses Jeopardy to teach medical students. It's quite an interesting game to play. I've never played this. I've never used it in my experience. But you can see you have different game boards, and the audience can choose what they want to play. And you can see there is an answer, and the students have to come up with the question. It's kind of counterintuitive, kind of interesting way to analyze a topic. Speaking of simulation, we'll have the next speaker talking more in detail about the IC simulator, which is going to be like a game. This is, from my personal experience, the IC simulation was like an actual game. I had to repeat the tasks. It gave me a score. There was a progress. There was an ultimate goal. There was a positive and negative feedback in real time. Probably the best example for our actual practice would be to use a surgical simulator. Chatbots. One of our teammates, the esteemed Dr. Eduardo, created a chatbot which is going to create artificial patient simulation experience. And this is a QR code to access that bot. I hope this works, because I just copied from Dr. Karl's slide, which you presented last time, so this should work.
I hope it does.
Yeah. Right. There are many case-based scenarios, case-based games available. Please go through that. The biggest lesson what I learned while preparing for this presentation is how interactive, how imaginative the other specialties are and how not creative we are. They're so creative, they have used almost everything available. This one U-Arcade by nephrologists, it's a fantastic game. But all of them have a fictional scene. They have characters in it. And this Clinical Sense is a wonderful app on App Store, which is again not for ophthalmologists, but made by general medicine and surgeons, which create a very interesting, like a house MD based clinical case scenarios. And Dr. Vipin Das will be talking on the VR, how we can use virtual reality in our teaching as well. So let's talk about the evidence. Some selected evidence, one in medical education and second ophthalmology education, not much in ophthalmology to be honest, and some of the drawbacks, what we face in gamification. These are two very nice articles, review articles, which I found online, and they kind of extensively discuss about the gamification. Although the first article does not discuss about the game shows like Jeopardy, and they don't take in consideration the simulation aspect of things. In ophthalmology education, limited literature, there is one interesting gamification done by from Pakistan, where students were divided into two groups. They had a Rexus tournament. They used simulation. They have these like tournaments like IPL cricket tournaments. They are like A versus B. A gets eliminated. So the first round, second round, we have a winner at the end of the tournament. Quite interesting, something which we can adapt in our practice, I believe. The escape room is another similar thing to Jeopardy, where the audience, in forms of teams, go to an escape room. The goal is to escape from that room. So don't ask me why they're going to the room. They go into the room to solve some puzzles, and when they solve the puzzle, they escape the room from the demon or from the problem. This is another interesting way where one of our colleagues from UK used escape rooms as a model to teach undergraduate students in ophthalmology. So we have some evidence, and what are the drawbacks which we can see from the various literature? The literature, what we have, they all have less control groups. They mostly say the students had their games in education, games in learning, they felt better, but there was no control groups to compare, to give a right evidence. And there's a lack of consensus on what is a game. There are many definitions for game. Some say game is not simulation. Some say game can be simulation. So there is a lot of controversies there. And like I said, the most important thing is how competitive you want that game to be. If you're going to be too competitive, which we don't want, the goal is not to win the game, the goal is to learn. So when students and teachers understand what the goal is, then our goal is attained. And as always, extrinsic motivation is what being focused on games. Points, medals, badges, leaderboard. But what's more important is the intrinsic motivation, how students are internally motivated to learn. So to summarize, we've got these essentials. Any game simulation, no matter what element we use to teach, should be based on adult learning principles. They stand the test of time. A game should have a clear goal and objectives. There should be a clear progress, a clear path, with an immediate, clear, positive or negative feedback, with a right balance of difficulty and easiness. Too difficult, they give up. Too easy, they get bored. And with a clear assessment of learning outcomes. Thank you so much for this opportunity. Thank you.
Any questions while we're getting the next speaker ready here? We should have time at the end too, so. Okay. Do you want to reintroduce?
I reintroduce Dr. George Saleh from Moorfields Eye Hospital, and he will discuss research in simulation for teaching and learning in ophthalmology.
Thank you. Thank you very much for having me again, and thank you for stepping up and rescuing me. Sorry, what do you need me to do? Audio is okay, I think. Oh, or maybe audio for this, yeah. Just to get a display. So actually, I think the order works really well because it's going to follow on very nicely from the last two speakers. Once we're up and running. So yeah, I'm going to talk a little bit about the brief Carl gave me was the research in simulation. So I've tried to stick to the brief. I have no no interest. But I have one thing to declare, which is I was having far too much fun yesterday, and a bit like you, I've added in a video from yesterday. So I'm going to talk about the two forms of simulation. There's a lower form of simulation, as my friend here on the left and I had a great time yesterday, and let's call it a higher form of or higher fidelity, as you can see here on the right. So this is me yesterday. Oh, shame the sound's not working. It adds a lot of vibrancy, if you could. So that's me in the back of this bike, going the wrong way up a road, which I'm sure for the locals is pretty normal practice. But I did have an extremely good time, and at the end of the hour, tipped the gentleman what he thought was far too much money, but it was best money I've spent since getting here. And the relevance of this to me was that I'm quite a keen cyclist, as you saw from the last slide, but there's always something to be learned by approaching something in a new way. And exactly the same way we were talking about levels of evidence and gaming. Life's a game. Surgical skills can be considered a game. And how to reinforce it and how to actually absorb it is something that has been described really well. So if you look here, there's loads of highest forms of evidence, systematic reviews and meta-analyses, and that's really what I try to stick to in terms of the brief. But most of these are cataracts. Most of these focus on either high fidelity, some of them on low, some of them are vitreoretinal, as you can see here at the bottom, which I'll come back to, and some of them are relating to skills labs, which is what I will start with. But in essence, what all of those papers suggest, I'll go back if you want to take another shot of that. All of these really suggest that blending all the different forms of education gives you by far and away the best form of learning. So trying to stick to one or the other or a third generally gives you less good outcomes. I think the other thing that's really important, we in ophthalmology, whilst we have all these great forms of education, great technology, have really quite low levels of evidence for educational outputs. And the forms and types of studies that we output are not of the same standard in terms of the viability for incorporation into meta-analyses and systematic reviews. So there's a lot more work that can and probably needs to be done to bolster the evidence. So at the lower end, and I take some issue with the low fidelity side of things because actually these are incredibly sophisticated, bioengineered pieces of kit, but there are quite a few different types, and I've had to play with most of these over the years. So this one you may be familiar with, these as well, the Kitaro here on the left, the Philips Eyes, which is here on the right, and I'll show you a couple of videos of that one. Again, one of the really interesting things about these sorts of kit is that they work much better when they're integrated with other forms of learning. So in a lot of the cases, certainly in the Philips Eyes, you've got an online resource where you can try and blend, and as you can see here at the top, you've got all the different types of subspecialties, and you can try and blend what you're doing practically with what you're doing cognitively and what you're trying to learn. I'm not a squint surgeon, but having had a play with this, and from what little memory of squint surgery from many, many years ago, it does certainly seem and looks realistic, and you can see from the videos here, that they seem to blend extremely well. And again, that systematic review and others do seem to suggest that putting these together can be extremely useful. In addition, you've got a lot of standalone platforms, so simulation in a more immersive setting, if you like, or more educational setting. So this is one example where you sit online and you learn prior to then going in, and so just-in-time simulation and various other forms of core learning. And this is far from an exhaustive list. There's a tremendous amount of great resources. There's Paul Sullivan's series. There's a whole load of online, a lot of other interactive stuff, which I think is extremely valuable. Again, sticking to the brief, the amount of published research on it, unfortunately, is quite low, but there are some extremely good bits of kit out there, which I'm sure will enter the more academic sphere. There have been some good papers on these two. So now moving on to the higher end of simulation. So we're looking at two platforms that have more recently entered. They've got much less evidence available on them, and they're, I think, less widely available than some of the other platforms that I'll come on to. But Immersive Touch is a North American platform from the USA, and it's basically an immersive company. So they deal with patient outcomes in an immersive setting, and they've moved into a more haptic type feedback. The Swedish company on the left here are more for a basic modular end of phaco training. The other company that have gone into the haptic feedback are Alcon. So they've recently released this one, which if you've had a play, is again very good. The main aim and the main part of the market is to be portable, and they've integrated it with their Centurion foot pedal. So those of you who do cataracts and use the Centurion, there's a good crossover there. It also fits in quite well, these haptic feedbacks, with the 3D viewing platform. So again, those of you who do cataract surgery, any of you who've tried these immersive, so these are the non-binocular, because you're not using a microscope, you put the 3D glasses on, you're using now a big screen. Ergonomically, it's very different. So for those of you who do cataract surgery, and like myself, for the last 25 years, I've used to do it one way, it's quite an ergonomic change to be looking at a screen away from the patient. But there are some potential benefits in terms of posture, in terms of certainly the teaching side of things, because you can have a large number of people, rather than just having a beam splitter, wearing the 3D glasses and actually getting a much better educational experience in the room. There are a number of other non-cataract related platforms. Almost all the vitreoretinal ones evolve around the VR Magic platform, which is an exceptionally good, but I'm not going to really focus on it, so apologies to any vitreoretinal surgeons in the room, because it is quite niche. There's a much bigger set of immersive platforms, and a much bigger set of simulative platforms for clinical training, which again, I'm not going to go massively into. Again, VR Magic have a big part of this market, but there's a lot of mobile phone related and other type apps which are brilliant, and I'd encourage you to look online for a lot of these. I think in the interest of time, I didn't go through those in more detail, but it's also guided much more to primary care as well as our own juniors. The IC, of course, has got the largest share of the market. That's the one we're most familiar with, and I think any of you who have used the machine are very well aware of many of its benefits. So it's very good at transferring skill, got lots of cataract-specific and generic modules, and there's quite good evidence that it does transpose an awful lot of skill, and it does make people generally more competent surgeons in cataract. That's, I think, quite well known. So what else has come along in the last few years? Well, the pandemic forced, obviously, a rethink of telementoring and remote training. And we took it upon ourselves with the social distancing in London to basically set up a remote platform. So what we're doing here is setting up a dial-in facility with a phone. We're outstreaming from the IC into the phone, into the laptop. And what that's allowed us to do is then remotely do the training. So that was very useful during the pandemic, but actually it's turned out to be incredibly useful. So I can train someone the other end of London, I could train someone here as long as we get our time zones right. So it's, I think, opened up the equitability of simulator access. Trainee can then go to the simulator that don't necessarily need to wait for the trainer to go there. And it's a really straightforward, simple, just need a mobile phone and a cable, out cable. So it's well worth, we've published this if you want to look at it. It's just a little, tiny little paper, but I think it was a useful addition. I've just stepped down from my role as the Royal College virtual and augmented reality lead, and we did a big piece of work looking at cost effectiveness. And these platforms cost a lot of money. And I remember talking at one of Carl's sessions about 15 years ago at the World Congress, and the hand went up saying, that's more than our entire annual budget. And they still are extremely expensive. Are they worth investing in? There's a lot of money to suggest that there is good outcomes. And this is, again, it depends on what your budget is, but if you've got the money, they definitely can offer huge potential benefits. So this was the NOD is it's a large pooled big data analytics set of research, which is done jointly with the Royal College of Ophthalmologists, and it pools tens and tens of thousands of cataracts. As you can see here, this study looked at just under 20,000, just over 15,000 cataracts, and it basically found at about a just under 40% reduction rate in PCR with the introduction of simulators. So that just shows the transposition. That was a really good level of evidence that highlights the benefits of high fidelity simulation, of course, in conjunction with the lower fidelity side. Now I'm going to run over by the looks of it. So the Help Me See are a charitable platform which have produced an incredibly good set of technologies, again, in conjunction with their whole course. So this is the mix simulator, and very usefully they've come out now with the phaco simulator as well. So if you get in touch with them, very well worth having a play. It's a charitable organization. It's all geared towards the third world. So whilst I've interacted with them a lot and I've had a play with their tech, we don't have one because we're not, well, some people might consider us, but we're not officially under the domain of what they're targeting. The other great innovation is Orbis. They have also developed now a high-fidelity simulator. This one I've not had a play with. Again, it's a haptic base, so very much like the other two. So again, I think this is incredibly exciting for opening up training to surgeons delivering around the world. This is the immersive. This is a huge area outside of ophthalmology that we haven't really adopted, and this is all about case-based and learnings from a cognitive, situational awareness, etc. point of view. And I put this in really for completeness. We did a trial on this, and there have been some peppered bits of evidence, but it hasn't been broadly adopted for whatever reason in ophthalmology. And there's some incredibly useful robotic platforms coming through. Again, these are all mainly vitreoretinal, so I've put them up for completeness. But I think this is going to be a huge area with AI integrating and additional degrees of stability. So the AI is the last thing I'm going to talk about, which many of you will know AI from various other domains. We developed a platform with Medtronic, so I'm just in the last few seconds, which I have actually run out of time. Let me just show you what we developed. This is basically an AI platform that in real time tracks cataract surgery, and it's incredibly useful, not just for the surgeon or the junior who's doing it, because it does phase transition, but it's operationally very useful. So you've got, this is the AI device. It tracks into your mobile. It's got a couple of extra screens in theater. And what you'll see here, in real time, it can then show you the phase that you're in and give you all the live metrics and analytics. And why that's useful is in terms of team training. If you've got your nursing staff who may be changing over or less familiar, they'll know that I will take X amount of time during my phaco, I'm about to overrun, what instruments I'm likely to use next, and because it can do all the tracking and recognition, it can then put that up on the main screen, which can then help with operational flow, operational getting patient throughput and safety, etc., rather than just the actual feedback for the surgeon. So this is as a team training and as a broader area, this may well have good applications. Sorry, I'm a few minutes over, but thank you very much.
Any questions or comments right at the moment?
Just pull it out.
Question?
Hi, great talk, George. Just
Thank
a comment. Our college, the Royal Australian New Zealand College of Ophthalmologists, we mandated IC training a few years ago for all our trainees. But be careful what you wish for, because all of a sudden then we had to buy enough simulators. And so I guess my concern is that does this then become a one-horse race for us? We're kind of narrow-casted into this one platform. And so there are going to be issues for us if a cheaper one comes along later, and yet we've mandated one. In your experience, is there interoperability between these, or is it like a Zeiss? Humphrey, you're stuck with it forever.
It's a brilliant question, and that was a big part of the report that actually should be publicly available in the coming weeks. I have finalized it, it's all been ratified. And in that, what we have looked at is the enormous cost, in our case, to UK PLC, which has many dozens, I'm not allowed to say exactly how many, but at the end of the 10-year lifespan, they then need renewal. They also need service contracts and so on and so forth. I see at the moment, I still take the view, I'm very grateful IC have invested and generated this tech, because it's created an awful lot of safety and saved an awful lot of eyes, even though it's incredibly expensive. I do suspect some of these other platforms will come on and rival. When, we don't know. So I think what we have tried to do is, as a country, is negotiate a bigger block contract. And the company are very willing to do that. If you're willing to purchase an X number knowing that you're going to renew, then, so I think you then have a purchasing power potential, and that might be an approach. They have engaged with us very well. It's actually our side getting the country to agree between themselves where you're going to place the simulators, how each trainee is going to be able to access. We have regional variants like we would do here and I know in the States. So are you going to allow your rival region to come in and use, and then what happens when they break? The probes are very expensive. So there's a lot of caveats to it. Until a technology comes along that rivals it, withdrawing it, we concluded, is a major safety risk. So it's something that we have to fund because the evidence is now there until an alternative comes along.
Yeah.
Thank you, George.
Thank you.
Now, next speaker will be Gabriela Annapalis, who has had extensive experience in education, first in the ICO and now in the Ophthalmology Foundation. She's from Buenos Aires, Argentina. And she will be talking to us on trends in curriculum development for resident training, entrustable professional activities. Gabby.
Thank you, but this is not my presentation here.
Oh. Can you change the presentation,
I'm not
please?
punchy one.
No, the previous one. Dr. Annapalis.
Thank you very much. I have no conflicts of interest. In fact, I don't know anyone in medical education who has conflicts of interest in medical education. So, the goal of my presentation will be to define entrustable professional activities, to describe the benefits they have in curriculum development, and to demonstrate an example. Entrustable professional activities were defined, or the concept was developed by Ole ten Cate, who is an educationalist working in the Netherlands, and he defined them as a unit of professional practice. This is what we clinicians do as daily work, such as, for example, performing a cataract surgery, or managing a patient with glaucoma, or designing a dry eye therapy protocol, that can be fully entrusted to a trainee once they can do it safely. EPAs have come to facilitate the translation of competency frameworks to practice. Competency frameworks in the last years have become very granular, and they are difficult to, each of the competencies are difficult to assess. In fact, the 2015 CanMEDS version has 700 components of competency, and this has been proved to be difficult to assess. So, entrustable professional activities have come to help with this problem. They describe work or tasks that residents can perform, and they are independent of persons, while competencies describe persons who have knowledge, skills, and attitudes, so they are more difficult to assess. EPAs integrate competencies, so for each activity, there are many competencies that can be assessed. For example, for performing a trabeculectomy, medical knowledge and patient care can be assessed, and for requesting a cornea donation, interpersonal and communication skills and professionalism can be assessed. Tied to entrustable professional activities are the entrustment decisions. And this is the decision to transfer a responsibility to a learner, to tell the learner that he is able to perform this activity independently. These decisions can be dichotomous: we entrust or not yet entrust the learner, or with decreasing levels of supervision. The first level, the learner will be allowed to be present and observe, but not to enact. The second level, he will be able to execute the activity with direct and proactive supervision, but with the supervisor present in the same room. The third level will be to execute without the supervisor, but the supervisor should be quickly available in the next room, for example. The fourth level will be to act unsupervised, and the fifth level will be he will be supervising other students or residents. There is little that has been published about entrustable professional activities in ophthalmology. This was the first paper actually by Hoff, Frenkel, and Imhoff. Imhoff is the ophthalmologist in this paper, and they have been using the EPAs in Ole ten Kates hospital that is in the Netherlands, in, sorry, I can't remember the name of the, Utrecht. And in fact, for the Association for Medical Education in Europe guide for describing EPAs, they have used an example related to cataract surgery. So it's an EPA for managing patients with cataract. So each EPA needs to have a title. The title has to be a simple one, and it has to be describing an activity. So for example, managing patients with cataract. Also, each EPA has specifications and limitations. We'll not see all of these because there are too many, but just to show a couple of examples. So the non-technical specifications, for example, are that the resident will need to know the medical history or the interpretation of specific investigations. The technical aspects of it will be the administration of local anesthesia or the performing vacuum emulsification and intraocular lens implantation. And the limitations of this EPA are that it does not apply for patients with high risk because of patient-related comorbidity conditions. The potential risk in case of failure, this also has to be part of the activity. So if the resident does not learn the activity properly, for example, intraoperative complications may occur, or undue financial costs and societal impact. Also, each EPA has the competency domains that are included in the activity, such as for this one would be medical expert, communicator, collaborator, or professional. Each activity should include the required knowledge, skills, attitudes, and experience that the resident needs to have or to live through to acquire this, the domain of this activity. So, for example, regarding knowledge in cataract surgery or in patients with cataract, he will need to know all the aspects of disorders of the lens. The technical skills required will be, for example, handling of the microscope and phaco machine. And the non-technical skills, an example of this would be adequate communication with the patient pre, per, and post-operatively. The experiences required will be the completion of the simulation training program, the wet lab training program, or at least 250 supervised cataract surgeries. Also, each activity needs to provide the information sources to assess the progress and support the summative assessment, such as video recording of 80% of procedures or 100 supervised satisfactory full OSATs in the operation suite. Each activity also needs to include when is which entrustment or supervision level expected. So, for example, in this case, in the Netherlands, the resident is expected to reach the unsupervised practice in his 4th year. And also, each activity has an expiry date. If the resident does not practice the activity for X time, in this case, if they don't practice cataract surgery for 2 months, they will be coming down to indirect supervision. The Royal College of Physicians and Surgeons of Canada have defined also the EPAs for ophthalmology. They have grouped them in 4 groups. Again, we will not see all of them, but just to show a couple of examples. The first group is transition to discipline. So, for example, this is for first-year residents. They need to learn to perform basic ophthalmology examinations or gather a history for patients with common ophthalmic presentations. The second group are the foundation EPAs, such as assessing and providing initial management for patients with uncomplicated medical and surgical presentations, or performing basic ophthalmic procedures. So there are 9 foundation EPAs for residents. The third group is the core EPAs. So here we have, for example, performing or interpreting diagnostic investigations, or performing retinal procedures or oculoplastic procedures. There are 15 in total that are core EPAs. And the transition to practice, which are to be learned by residents in their last years, such as teaching other learners or running an outpatient clinic. When building a curriculum with EPAs, the recommendations are to identify first the EPAs that are relevant for your own setting, to create a full description of the EPAs, or to take some that have been described already, but to adapt them to your own setting, to determine how they are going to be assessed, and to establish the way that the residents are going to learn them. So in conclusion, EPAs represent what we do in our jobs. They allow to translate the competency frameworks to clinical practice, and they provide transparency to training and assessment through trust. That is what we usually do when we say that our residents are able or not able to do an activity. Thank you.
So I have a question. So it seems like a lot of work to create these. What do you think the benefit is
The benefit?
of having EPAs?
The benefit is that they are more easy to assess, I think. Because they describe activities, you will not probably have to go through all of the granular aspects of competencies defined in competency frameworks. So that's the benefit.
Any other questions? Or go to the mic, yeah.
Yeah, I have a doubt. EPS, if we introduce, what about like if it's a fixed curriculum, fixed course, like 3 years or 5 years, and if a resident does not achieve that particular level of EPA, so do we still allow them to move ahead? Or because this goes with a variable course, it's fine. But what if it's a fixed course and we bring in EPAs?
The other benefit of the EPAs are that you do not need to have a fixed program where the resident has to achieve a specific EPA in a specific amount of time. So you can give them more time to learn that activity. I don't know if that's a question.
So the program has to change then. Like if we can't have a fixed program, like post-graduation we have for 3 years or 5 years.
If you have a fixed program, I don't know.
Well, I think the question is, what do you do if they're not meeting their, they're not progressing as you want them to? And I mean, I guess all you can say is, if they don't, then yeah. If they don't, remediation. I mean, I think the most important point to your question is identifying it really early, so that you can give them the feedback and whatever the advice is to get them to get where they want to be. If it's all of a sudden you realize, oh, it's year 3 and they haven't met the criteria, well, hopefully you've been telling them that all the way through, not just at year 3, because our goal, of course, is for every student, every resident to become a competent ophthalmologist. So I think early identification, which means you have to have early assessment methods and to let them know, okay, you're not moving along like you should be, here's what we need to do. So it requires a lot from the teachers, the faculty, to give the good and constructive feedback and to work with them. And if they can't, and ultimately if they can't do it, then you can't let them graduate. I mean, would be my opinion.
The second thing is same with APS. How do we had done some work in my previous institute, that's why I'm asking. You said recordings, because once we have EPS in the curriculum, there has to be evidence to support that. So for all the EPAs, creating evidence ideally needs an e-portfolio, something like that, which all the institutes may not have. So I think it needs a lot of groundwork before we bring in EPAs.
You need multiple assessment methods to make sure they're progressing as you want them to progress.
Thank you.
Okay, our next speaker could not make it because he could not get a visa, but he did supply a video presentation. So this is Hongji Wang, and his talk is on evidence on best practices for teaching ophthalmology to medical students.
Thank you, Professor Carl and Professor Gabriela, for inviting me. It is my honor to share our thoughts about the evidence on the best practice for teaching ophthalmology. So good morning, everyone. I'm Hong Xiwan from Joint Shantou International Eye Center of Shantou University and the Chinese University of Hong Kong. There is no conflict of interest. We know that the evidence-based practice is an important idea for modern management, which is characteristic by the use of high-quality research in making decisions. The Center for Evidence-Based Management has proposed the 6A's process: asking, acquiring, appraising, aggregating, applying, and finally assessing. This process ensures that the decisions are made based on the most reliable and relevant information. So, how to use it to engage the best teaching practice? Firstly, you should ask unanswerable questions from the teaching issue. Various aspects within the learning ideology interact and contribute to the learning. So, is there any relationship among the factors? Does the teaching practice work? And remember, these questions should be learner-centered. A trained ophthalmologist might forget the initial process from unknown to known, so sometimes your questions might be just your wishful thinking. And after systematically searching for and retrieving the evidence according to the questions, we should critically judge the trustworthiness of the evidence. Traditionally, we grade the level of evidence by the study design. But the new pyramid with wavy lines indicated even for RCT, if poor designed, the evidence could be weak. And besides, the systematic review and meta-analysis become the lens through which the evidence is critically viewed. So there are some instruments for study quality assessment for reviewers or evidence-based practitioners. The most commonly used is the NIH tool, which is specific to certain study designs. For example, for controlled intervention study, there are 14 items for you to test the potential flaws and assess the risk of bias. Another tool called MERSQI is more specific to medical education research. You can also choose to apply. For example, we know that teaching ophthalmoscopy is very difficult. So is there any simulations tools or digital alternatives? You can search the keywords in PubMed, and you may be very happy to find this systematic review since it has completed acquiring and appraising. The authors found 20 relevant articles and summarized using 2 big tables. Then they used the NIH tool to assess the risk of bias and found most papers fail to consider randomization, blinding, and sample size calculation. Only 2 studies satisfy all NIH criteria, which are highly qualified and should be referred firstly. So let's have a look at this one. It is my work. You can further refer the methods that we illustrate in the article. See how to guide the students to assemble the smartphone ophthalmoscope using their own mobile phone, and then use it to visualize the retina for each other, and catch the image and record a video. Besides, we should also apply the evidence relevance and reliability. It is an RCT with a crossover design. In the first session, the Group A students were taught with traditional direct ophthalmoscopy, while Group B was taught using the smartphone. And in the second session, the training was crossover. This design allows both groups to receive almost the same intervention, which ensure the access and equality. Besides, we can use ANOVA to dissect the source of score variation There should be a difference between the first and second session, and also difference between the group A and group B. After adjusting these factors, the remaining variation should be due to the tools. Therefore, the conclusion that the smartphone helps the medical student to view the retina more precisely is reliable. So after reviewing the literature, we pull the evidence together and make decisions. And this process requires the consideration of the other two dimensions, teaching experience and the student's value. Here lists some problem: the cost, the time. There was a global decline in ophthalmology course lengths over the last 2 decades, and most of our medical students won't specialize in ophthalmology. So are they worried? And recently, we conduct a systematic review on the topic about the use of the classroom in teaching ophthalmology to undergraduates. So some authors concerned about the students' preference and pressure, which also incorporate this finding when introducing the new teaching tool into implementation, or better to determine some specific suitable chapters for flipping. The teaching experience is also variable, although previous practice has heavily relied on it. Even so, we should make it more reliable. We can use the Delphi method to conduct structured surveys for expert panelism. Finally, a conversion outcome, consensus, checklist, or a standardized curriculum like this one shown here was made. After applying the teaching evidence, don't forget to assess the outcome. So we should do comparison better with controlled group. And the outcome measures contains not only the performance, but also the teacher and students' feedback and the long-term patient care effect. Here is another question, also focusing on the ophthalmoscopy. How to measure the capacity for undergraduates? Are the following instruments valid? So these questions depends on your objective. We know that completing the procedure step by step doesn't guarantee viewing the retina. However, requirement of giving diagnosis after ophthalmoscopy is challenging and not suitable for undergraduates. So, focusing on the visualization, we develop a simple eye model with some single letters on the folders. The students are asked to use the ophthalmoscope to view the model and view the pictures within 5 minutes. This task-oriented examination has been proven as moderately difficult and with high discrimination to differentiate between the poor and competent performers compared with the DOPS assessment. Finally, if there is few reported evidence, just conduct a study by yourself. We raise a Q-point mode to summarize the process of teaching study. Take our mock study as an example. Firstly, facing the declines in ophthalmology course over the years. Is there any resource facilitate the learning? We found MOOC was effective in other courses, so we constructed ophthalmology MOOC. But that's not all. We designed a research project and operate the experimental study, collect data from the students and found evidence. And afterward, the MOOC is open to the students as an online learning resources. This organized evidence-based teaching is now widely implemented in our university, college, and hospital. I would like to express my gratitude to the JSIEC teaching staff and students for their contribution. In conclusion, evidence-based practice in teaching ophthalmology requires critical and comprehensive thinking. By adhering to the 6A's process and taking consideration to the 3 dimensions, and conducting experimental study using the Q-point mode, we can ensure that our teaching are effective and grounded in the best evidence. This approach benefits our students and contributes to the advancement of ophthalmology education. And thank you for your attention.
Okay, all right, very good. I don't think we have the last presenter here, unless I'm not recognizing him, I should. And his talk, I know, was not uploaded, so I think that would be the end of the symposium, although obviously we have time for questions. Are there any questions before we close the session, or comments? If there are none, then thank you for participating, and thank you for coming. Thanks the speakers, the moderators, and have a great rest of the meeting. I know, it's freezing in here.